wassce 2020 Elective Mathematics Question 14. The ends x and y of an inextensible string 27 meters long are fixed at 2 points on the same horizontal line, which are 20 meters apart. A particle of mass 7.5 kg is suspended from a point P on the string 12 meters from X. Illustrate this information in a diagram. Calculate correct to 2 decimal places angle YXP and angle XYP. Find correct to the nearest hundredth the magnitudes of the tensions in the string. Take G equal 10 meters per second squared. So now let's illustrate this on a diagram. We're told that the ends x and y of the string were fixed at 2 points. So let this be our string, and the ends are this. So this is the string. We cannot extend it. It is inextensible. So the length will always be 27 meters. Now let's fix these 2 points to, let's fix the ends to these 2 points over here. So no matter what the point is, it's also going to coincide with x and y. Now this is the string which is slacking over here. The next thing we need to do is to suspend a mass of 7.5 kg. So let's this be the mass of 7.5 kg, and we are suspending it at a distance of x. So we move from x 12 meters. We move 12 meters from x and suspend the mass or the particle P. So this is the particle P, and the mass of that particle is 7.5 kg. Now when we leave this, it's going to exert some weight on the string, so that there will be some kind of tension exerting upwards. Good. So we will see that the distance from x to P is 12 meters, and the distance from y to P will be 50 meters. Because the string cannot extend, the total length of the string will still be 27. That is 15 plus 12 meters. So it is the weight that stretches the string like this, and the tension, the tension force were acting in the opposite direction. So now we've managed to illustrate this information in a diagram. The next thing is to calculate correct to 2 decimal places angle YXP, this angle, and angle XYP, this angle. So we know that we can do that by using the Cosine Rule together with the Sine Rule. So we know the Cosine Rule is given by a squared equal b squared plus c squared minus 2ab cos a. So there's a mistake here. 2 times ab cos a. So that's the Cosine Rule for you. Now the next thing we do is to apply this Cosine Rule and the Sine Rule on this. So using the Cosine Rule, let's try finding this angle first. So 15 squared will be equal to 12 squared plus 20 squared minus 2 times 20 times 12 cos cos of angle YXP. So that is what we did here, and we had this. Now we've seen it. Now the next thing we do is to simplify this. 15 squared will be 225 equal to 144 plus 400 minus 480 cosine of angle YXP. Now what do we do next? We simplify further. Now when we evaluate on the left, we get negative 319, and this will also give us negative 480 cosine of angle YXP on the right. Now I'll divide through by negative 480 and simplify. So that will give us angle YXP to be equal to the cos inverse of 319 over 480. And when you calculate that correct to 2 decimal places, you get 37.12 degrees. So you can work to 3 decimal places before you correct to 2 decimal places. Now we've managed to find this angle. Now to find this angle, we can quickly apply the sine rule. Sine A over A will be equal to sine of angle B over B. When we do that, we get something like this. Sine of angle XYP over 12 meters is equal to sine of angle, this angle over here, over 15. So when we do that, we simplify by multiplying both sides by 12. Then that will give us sine of angle XYP is equal to 0.48266. Now take sine inverse of both sides to obtain the angle correct to 2 decimal places as 28.86 degrees. Now what do we do next? We are supposed to find correct to the nearest 100th, which is the same as to 2 decimal places, the magnitudes of the tensions in the string. So we need to calculate the weight here and also calculate the tension force. So when we calculate the weight, we obtain something like this over here. So the weight will be 7.5 times 10, which is equal to 75 Newton. Now what do we do next? We have to resolve these forces, these tension forces. Tension 1, tension 2. Then we know that this angle here is equal to this angle because of alternate angles theorem. And the same thing applies to this side also. So what do we do? To resolve these forces, we resolve into horizontal and vertical component. So that will be given by, we know this angle is the angle created with the x-axis. So it is also in the quadrant where x is negative and y is positive. So for the tension 1, the resolution is given by this magnitude of the tension times the cosine of the angle it makes with the x-axis. The negative sign here is because x is negative in this quadrant. Then the same thing applies to the vertical component, magnitude of the tension 1 times the sine of the angle it makes with the x-axis. So when we simplify this, we get this. So use your calculator to obtain something like this. Now the next thing we do is to resolve tension 2, and that will give us this. So in this quadrant, this is the first quadrant, and both x and y are positive. Then we resolve the weight. So the weight over here is making an angle of 90 with the x-axis. So the resolution is W equals 75 cos 90, then negative 75 sin 90, because y is negative over here. So the body is now in equilibrium. So if we add all the forces acting on it, we should get 0. And this will give us two simultaneous equations in T1 and T2. And we need to obtain the equations as follows. Negative 0.797 for T1 plus 0.8758 magnitude of T2 equals 0. That is taking the x component. Then if you take the y component, you also obtain this second equation. So I will leave this for you to solve simultaneously to obtain the magnitude of the first tension to be equal to 71.91 newtons, and the magnitude of the second tension to be equal to 65.47 newtons. Now, if you can still see this red in here, it means you have not yet subscribed. So you just have to click it so that the next upload, see it is still red. You have to click it so that if I upload the next video, you'll be informed. Click the bell icon too so that you get a notification whenever I upload a new video. Thanks for watching. Don't forget to subscribe.